Friends, in this video, we'll see one of the spell checking method used in the NLP. That is the minimum edit distance method. It's a kind of dynamic programming based approach. Okay. Minimum edit distance means here each and every spelling can be substituted to another spelling with the help of some techniques known as insertion, deletion, or substitution. Okay. The techniques are insertion, substitution, and deletion. Here, this is mainly used to find the similarity between the strings. Suppose you have typing one word cat and another one dog. To find the similarity between these two words, there is no similarity between these two words. If there are any similarities occurred between these two words, this can be calculated by using the technique called as minimum edit distance method. The basic operation needed in this minimum edit distance method are insertion, deletion, and the substitution. Minimum edit distance means it's the distance between two strings, string 1 as well as string 2. By using these three techniques, insertion, deletion, and the substitution. For example, consider the string AB. You are going to convert the string AB into ABC. In this one, first two symbols are same, AB and AB. For the string 2, we need one insertion. That is here we are inserting the symbol C. So the minimum edit distance between AB and ABC is 1. We are performing only one operation, that is the insertion. Based on this technique, we will calculate the minimum distance between the strings. This is basically used for spell checking in the NLP. Consider these two words, intention and execution. Before finding the minimum distance between the sentences, first we should take care of the alignment. If there are common substrings, then we should align the string based on the common substrings. Here in intention and execution, TION is common. Similarly, E is also common. Here E as well as TION is common. So we should align the string based on that one. Consider TION. This word TION as well as E is common. So I have aligned like this one. TION is common. So I am aligning TION here. And intention, INTEE. Here this E as well as this E is common. So I have aligned this E as well as this E also. Remaining, leave the space or insert the values. So this is the intention and this is the execution. To convert the intention into execution, what are the things required? Means first I have deleted this I. No need for this I in this execution. And next one is here I have converted this N into E. So that is the substitution. We will perform only three operations: delete, substitute, as well as the insert. Then T is converted into X. So that is again the substitution. E, no need to change anything. So nothing can be done here. Then star, instead of star, here I have included C. So here I insert the value C. And N is converted into U. Remaining things are same. Hence, here the operations required are, first one is delete operation. So distance is 1. And second one is the substitute operation. N is substituted as E. So here the distance is 1. So 1 plus 1 equal to 2. And then T is converted into X. So here also I need one operation. So 3 operations. Next one, no need for any substitution, insertion, or deletion. The next one is star is converted into C. Hence, star is converted into C. We need the insertion operation. So 4. And here this N is converted into U. So 5. Totally, the edit distance between these two are 5. So here the alignment plays a major role. And here for the edit distance method, we are using the dynamic programming based approach. Dynamic programming based approach means initially to perform this operation, instead of doing like this one, we can find a two-dimensional table. First, place the two-dimensional array or two-dimensional table. I'll explain how to calculate the minimum edit distance between two small values. Based on that, we will type the algorithm also. For example, consider here kitten to sitten. Now we need to substitute S instead of K. So the operation, only one operation is required. That is the substitution operation. Then what is the minimum edit distance here? 1. Based on that, we will calculate. It can be calculated in a easier manner. First, before doing anything, first form the two-dimensional array, 2D array. In the row, write one letter and the column, write another string. The first string is written in the row and the second string is written in the column. For example, consider in this example, I am taking mat as well as cat. I am going to find the edit distance, minimum edit distance between the mat and the cat. To find the distance between mat and the cat, first write mat in the row and cat in the column. The next step is here include 0 in the diagonal, first diagonal. Here, this is the first diagonal. In the diagonal position, you include. So in the diagonal position, you are going to include 0 first. That's the first step, 0. Then in the row wise, include 1, 2, 3. Okay. First diagonal 0, 0 plus 1, 1, 1 plus 1, 2, 2 plus 1, 3. Like that, you include the values in the row. Same manner, include the values in the columns also. So consider row as I and column as j. In I, first insert 0 and increment the values plus 1, plus 1, plus 1. Same manner, include the values in the columns also. What are the values? 0, then 1, 2, 3. Increment the values and write. So this is the first step. Whatever be the string, write the string and give the 0 in the first diagonal space and 1, 2, 3 in the rows and the columns. This is the first step used in the edit distance method and the dynamic programming. This algorithm is otherwise called as the Levenshtein's algorithm. The next step is, first you should fill the rows. Okay. First, we are going to fill all the rows. One by one, we are going to fill the rows. What's the first one? C and M. Find the distance between, that is, you are going to find the edit distance between this C as well as M. C as well as M. This place is for C as well as M. To fill this one, find these two are the different. The main objective is to find the similarity. Find, is there any difference between the strings? M and C are different. If both are different, then consider this one. If both symbols are different, both are same means another method. If both are different, consider this upper value, left value, and the diagonal value. Okay, that is this row value, column value, as well as the diagonal value. This value is called as insert value, delete value, and substitute value. Find these three values. Among these three values, take the minimum value. Hence only it's called as the minimum edit distance. Take whatever be the minimum value plus 1. Because here we need some substitution, right? Substitution, we are going to substitute. One operation we are going to do. Hence, 1, 0, 1. What is the minimum value here? The minimum value is 0. 0 plus 1. What is 0 plus 1? 1. Okay, fine. So 1 is inserted here. Same manner. Go and check C and A next. Next, we are going to check C as well as A. This C as well as A. Okay, so this is the place corresponds to C and A. For filling this one, here also C, A is substituted as C. We are going to convert mat to cat. A can be substituted by C. So here also we need a substitution operation. We are going to calculate the value. So here you find this 1, 1, 2. What is the minimum value? Take the minimum value. The minimum value is 1. Fine. Minimum value plus 1. 1 plus 1. What will be the value? 2. Okay. Then we will calculate the minimum distance between C and T. Next step is take the minimum distance between C and T. So this place belongs to this one. So what will be the value? Again, see the diagonal value, upper value, and leftmost value. The minimum value is 2. 2 plus 1, the value is 3. Same manner, fill all the columns. Now I am going to check the minimum value between A and M. A as well as M. Here also substitution is required. So A and M, find the values 1, 1, 2. 1, 1 and 2. What is the minimum value? 1 is the minimum value. So add 1 to the 1. 1 plus 1 equal to 2. The next step is, that is very, very important. Listen this one. Here next is A and A. There is no substitution. A is written as A. So in that case, no need to add the values. That is, we are not doing any operation. Instead, move this diagonal value here. This is very, very important in this algorithm. Move the diagonal value. Okay, here substitution. No need for substitution. So move that diagonal value directly here. So what will be the value here? 1. Fine. The next is A and T. Consider A and T. Here the substitution is required. T is substituted as A. Hence, find the minimum value 1, 2. The values are 1, 2, and 3. Refer these three values. Among these three values, the minimum value is 1. 1 plus 1 equal to 2. Then go here, T and M. M is replaced as T. So in this situation, what are the values you should refer? M and T. So refer these three values. When you refer these three values, minimum value is 2. So 2 plus 1. 2 plus 1 will be 3. Hence here also A is converted into T. So consider these three values. And here the minimum value is 1. So 1 plus 1. What will be the value? The value is 2. Same manner T and T. So T and T, we find the value that is same. If both the values are same, then transpose this one here. So this value is 1. Like this, the values can be calculated, substituted. Finally, see this diagonal. Here, the value is equal to 1. That is the minimum distance. Now you can see mat and cat. Mat, to convert mat into cat, you replace M with C. That is substitute C instead of M. So how many operations required by viewing the string? We know that only one operation is required. So what is the minimum edit distance? 1. That is calculated. So in dynamic programming method, it can be calculated. This is the technique used for finding the similarity between the string. Now you will calculate the minimum distance between the execution and intention by using the same concept. You can say the answer, execution as well as the intention. Same thing. Initially fill this diagonal as 0, then increment 0 plus 1, 1, 2, 2 plus 1, 3, 4, like that. Increment all the values here. Same manner, first write all the row values, then write all the column values. What will be the next thing? We are going to compare these two things. Compare this E and I. E and I both are different. If both are different, then what we will do? We will find the minimum value across the diagonal and place that value. Minimum value across the diagonal is 0 and that value plus 1. We are doing the substitution to indicate that minimum value plus 1. So minimum value plus 1 is, here you can write this as 1. Same manner, X and I. First fill all the row values. X and I. X and I. When you compare these two values, both are different. That is your performing replacement. So find the minimum value over here. The minimum value over here is 1. 1 plus 1 is equal to 2. Then I and E. This is also different. So if it is different, find this three values. 2. 2 plus 1 is 3. Like that one, you replace the values. I and C is different. So 3 plus 1 is 4. Like that you should do. When you see here, this is E as well as this one is E. In that situation, you will process this one here. Like that manner, you fill all the values. You will get the answer. So this is the minimum edit distance method. By using the dynamic programming concept, we know that this is the algorithm for this one. What is the first step? First one is we take the string, source string as well as the destination string. String 1 as well as the string 2. Create a distant matrix. If the length of the string is n as well as m, then we will form a two diagonal matrix of a size n plus 1 and m plus 1. First step is the initialization. How can you initialize? The leftmost corner is initialized as 0. The diagonal is initialized as 0. And first rows are indicated by I and columns are indicated by j. So rows are indicated as I and it changes from 1 to n. Okay, first one is 0, 0 plus 1, 1 plus 1, 2, 2 plus 1, like 0, n dimension. Same manner, columns are also indicated as 0 to m direction. First, initialize all the values. That's the initialization. The next one is fill the values. For filling the value, for each row and column, find the minimum value along this row as well as the left side as well as the diagonal. That's what written here. I minus 1 into j, I comma j minus 1. That is previous row, previous column as well as diagonal. Diagonal means I minus 1 into j minus 1. The diagonal values. Minimum of all these things are calculated and cost of that. Cost means number of substitution 1. That is included. Finally terminated. This is the algorithm that it picked the minimum edit distance method. So this is for strength as well as strength. Understand the concept now? Here E and E. If it is the same string, if it is same, then the diagonal value is placed here. If it is different, then here this is different. So consider T and T. Here also it's same. If it is same, this diagonal is processed and placed here. And consider this G. This G and N. If it is G and N, then these are different. In that situation, minimum value is taken from these three and the minimum value is 1. So 1 plus 1, that is equal to 2. 1 plus 1, 2 is placed here. This is the concept of minimum edit distance, and this is otherwise called as Levenshtein's distance algorithm. This method is used to find the similarity between the string. Based on this only, whichever being the higher similarity string, that is replaced instead of the existing. That is, if you are entering the wrong letter, it can be replaced by the higher similarity string. This is one of the technique used for replacing the errors or correcting or error correction in the NLP algorithms or any NLP tool. This is one of the technique used for the error correction. Okay, thank you.